Hey everyone, in this video we have a function and we're going to find the relative extrema of that function using what's called the second derivative test. So before we do the problem, let me recall a couple things that we're going to use in this problem. So the first thing we're going to use is the product rule, because when we take the derivative of this thing, we got to use the product rule. So the product rule says if you have f times g, the derivative is the derivative of the first piece, which is f, times the second piece, which is g, plus the first piece times the derivative of the second. That's how I do the product rule. The next thing to recall is the second derivative test. That basically means we find all the critical numbers and plug them into the second derivative. If the second derivative is positive at a critical number, we have a minimum at that critical number. If the second derivative is negative, we have a maximum. Okay, so we'll go through the problem now. So solution. So the first step in this problem is take the derivative and set it equal to 0. So let's do it. So f prime of x. So here, this is the first piece, and this is the second piece. So we're going to use the product rule. So the derivative of the first piece is the derivative of x, which is 1, times the second. So sinh of x minus 1, minus the first, plus the first piece, times the derivative of sinh. The derivative of sinh is cosinh, so it'll be cosinh x minus 1. And then we're supposed to use the chain rule, right, because we have an inside function. So the derivative of the inside here is just 1. That's because the derivative of x is 1. Let me go over that again. So the derivative of the first piece is 1, times the second piece, which is sinh, plus the first piece, which is x, times the derivative of sinh, which is just cosinh, and then you have to multiply by the derivative of the inside function, which is just 1. Okay? Then minus, and then again the derivative of cosinh, well that's just sinh, so it'll be sinh x minus 1 times, again chain rule, derivative of the inside is 1. Oh, this is really cool. All right, they cancel. So you get f prime of x equals x cosinh of x minus 1. So that's the first derivative, and we want to set this equal to 0 in order to use our second derivative test. All right, we have a product equal to 0, so we can set each factor equal to 0. So x is 0, or cosinh of x minus 1 is equal to 0. Okay, so 0 will work. No problems with 0. It's a place where the first derivative is 0. It's in the domain of our function. It's a critical number, no issues. Right, critical numbers are numbers in the domain of the function where the derivative is 0 or where it's undefined. This is never undefined, and 0 is certainly one place where the derivative is 0. What about this? Well, cosinh is never 0, so this can never happen. So it's impossible, so no. Okay, it can't happen. If you're not convinced, you can use the definition of cosinh. In this case, cosinh of x minus 1 would be e to the x minus 1 plus e to the negative x minus 1 over 2 equals 0. This is positive plus positive. There's no way it can be 0. Game over. Okay, so x is equal to 0. That's our critical number. So now all we have to do is take the derivative again and plug in 0. If the result is positive, we have a min. If the result is negative, we have a max. So let's do it. Take the derivative one more time. So f double prime of x. So again, using the product rule, the derivative of the first is 1 times the second piece. So cosinh of x minus 1 plus the first piece times the derivative of cosinh, which is sinh of x minus 1. And again, we have to multiply by the derivative of the inside, which is 1. So that is the second derivative. Let's check that. So it's the derivative of the first, which is 1. Boom. Times the second, right there, plus the first, which is x, times the derivative of cosinh, which is sinh of x minus 1, and then chain rule. That's where that 1 comes from. Now we're going to plug in our critical number into the second derivative. That's what the second derivative test says. So we take the 0 and we just put it there where the x is. So 0. So we get cosinh of 0 minus 1. So we get cosinh of negative 1, right? Cosinh of negative 1. Okay. And this is positive, right? This is positive because cosinh is always positive, right? So we have, should be two words, not we have a min, right? at x equals 0, right? Because Whenever the second derivative is positive at a critical number, we have a min. If it's negative, we have a max, right? So now all we have to do is find the actual minimum value, right? So to find the minimum value, we take this 0 and we go back to the original function, right? So f of 0, well, you put a 0 here, you're just going to get 0 minus cosh of 0 minus 1. So we get minus cosh of negative 1. So that would be the minimum value. That would be the min. So we have a relative min, I'll put rel min, of negative cosh negative 1. Most people, most books, they'll write it as an ordered pair. So that you can say the relative min occurs at the ordered pair 0, comma, negative cosh of negative 1. So that's how most books will describe the answer. But the actual minimum is this. Remember, minimums are y values, so not ordered pairs. That's it.